Hey y'all, and welcome back. Today we'll be talking about number patterns and how they relate to rules. A rule is an equation that helps us to change a number in a predictable way. We can use a rule and pick any number we want in the whole world, and if we follow the rule, we'll get out a very predictable result. We'll get a very predictable output. Let's look at an example. If I had the rule x plus 7 equals y, the rule x plus 7 equals y, x and y are both variables. They're numbers we don't know yet. They could be a lot of different numbers. What we can do in order to find some of those numbers that they could be is to put them into a table. We can look at this table to create a number pattern. So let's try it out. What this rule says is that no matter what I choose for x, I can figure out what the y should be by always adding 7. So I'm just going to try some different numbers. What if I decide to pretend that that x is 1? Well, if the x is 1, then I would add 7 to it because it says x plus 7 to figure out what y is. We can all do it. 1 plus 7, that's 8. So if x is 1, if our input x is 1, then our output y has to be equal to 8. All we're doing there is we're taking a rule and we're choosing one of the letters to plug in. We can choose any number we want in the whole world. I like to use easy numbers like 0 and 1 and 2 because those are really easy to add and subtract and multiply and divide with. But you can use any number you'd like in order to fill out the chart. Let's try another one. So I've got x plus 7 is equal to y. I said we could pretend that that x is 1. But it doesn't have to be 1. That x could be a lot of different things. In fact, let's say I pretend that this x is 2. If I pretend that the x is 2, 2 plus 7, what would my y have to be? I bet all of you see it already. 2 plus 7 gives us out a 9. Okay, so if I put in a 2, I'll get out a 9. All right, I'm going to put in an input up here, and I want you to tell me what the output should be. If I put in an input of 5, notice how it's not following the same pattern. It's not 1, 2, and then 3. I just chose any number I felt like. I'm choosing 5 this time. What would my output be? Pause the video and see if you can figure it out. All right, I asked you, what would happen if my input was 5? What would happen if I pretended that my input was 5? Well, my input, the thing that's inside, that's having numbers act upon it, that's either getting added or subtracted or multiplied or divided, what I'm going to do is I'm going to plug in a 5. Instead of writing x, I'm going to write 5. Then I write the whole rest of the rule. Now I can solve it because 5 plus 7 gives us 12. So if we pretend that 5 is our x, then we have to pretend that 12 is our y. That's how we can change a rule into a table. All right, what if instead they gave us a table and they asked us to change it into a rule? Okay, so now I'm going to write in here a table and I'm going to see what can I do to change that into a rule. So let's go with, I've got some easy inputs of 1 and 2 and 3. I'll make them super simple this time. And our outputs, let's go with 4 and 8 and 12. In order to figure out what the rule is, I have to try 2 different things. I have to look at this input and look at the output, and I have to say, how can I make this input change into the output? Well, I can either add something to it, or I can multiply it by something. Let's test out what I would have to do. It's either 1 plus 3 gives us 4, or it's 1 times 4 gives us 4. How do you think I can figure out which one of these it is? Because it can't be both of those for my rule. Pause the video and see if you can figure it out. When you're done, come back and I'll show you. Okay, so the way that I figure it out is I look at my next set of inputs and outputs. When I look at this 2, if it's following the same rule, which is plus 3, then I should be able to add 3 to 2 and get this answer. But 2 plus 3, that doesn't give me 8. So we know it's not the plus 3. 2 times 4 gives me 8 though. And if I check my last one, 3 times 4 gives me 12. That means that my rule is multiplicative. I'm multiplying to figure out how to get my input to change into my output. Let's write that rule. Here we're saying x, our input, and then I'm multiplying times 4. And this is why mathematicians usually use this star as they're multiplying once they start getting x as a variable. X times 4 gives them their output. Their output is y. So x times 4 is equal to y. Sometimes you might see mathematicians being lazy and saying 4 x's is equal to y, but that's the same thing. No matter how you write it, that's the same thing. This is x times 4 is equal to y, or 4 x's is equal to y. Let's try another one. Let's try one where I give you the rule and you fill out the input-output table. So I'm going to give you the rule. The rule here would be x times 3 equals y. Go ahead and pick any 3 numbers you'd like for your input, and then figure out what your output should be. For me, I'm going to choose 0, 1, and 2, because I always think those are the easiest ones to work with. But you don't have to choose those 3. Choose your own 3 and figure out what the output should be. Pause the video, and when you're done, come on back. Okay, so to figure out my outputs, all I'm going to do is I'm going to plug in my inputs. I'm going to pretend, if I pretend for a second, that the x is 0, 0 times 3 gives me 0. So I know that my y has to be 0. What if I pretend for a second that the x is a 1? 1 times 3 gives me 3. So I would have to pretend that my y is a 3. What if I pretend for a second that my x is a 2? 2 times 3 gives us 6. So that means that I'd have to pretend my y is a 6. Here I've got my input-output chart. All I've done is I've taken my inputs and I've plugged them into my rules. How'd you do? Did you get the same answers as me? All right, let's try it the other way again. We've done a rule to a table. Now I want to give you a chance to change a table into a rule. We just looked at a multiplicative rule, so I'll give you a hint. This time, the rule is going to be additive. This time, the rule is going to be additive. So again, choose any. I'm going to choose the inputs for you, 1, 0, 1, and 2. And I want you to figure out what the rule is when I tell you what these outputs are. So I'm going to have an output of 5, and 6, and 7. Okay? Pause the video and see if you can figure out what our rule is. When you're done, come on back. Okay, to figure out our rule, here's how it works. I say, what could I do to my input to make it into my output? Well, I could either be doing plus 5, or I could be doing times, wait a second, there's nothing I can multiply times 0 to give me 5. So if there's nothing I can multiply times 0 to give me 5, this doesn't even work. There's nothing I can multiply. Let's look at our next one. I could be doing plus 5, or I could be doing times 6. Okay, well that's two options there. It looks like it's probably going to be plus 5 because this one also had a plus 5. Let's try our last one. 2 plus 5 would give me 7, and 2 times 7 halves would give me 7. Well, times 6 and times 7 halves, those aren't the same. So we know it's not going to be multiplying. Instead, this is an additive rule. What I'm doing is each and every one of these had a plus 5 as one way that they could change their input to their output. So I'll write in my rule. X, my input, plus the 5, which I said is happening in each one of these charts, is going to equal y, our output. X plus 5 is equal to y. And I could write this, if I wanted to, a slightly different way. 5 plus the x is equal to y. All I'm doing there is I'm using the commutative property. I could even, if I wanted to, put the y on this side and the 5 plus x on the other side. But as long as you've got x getting added with 5 is equal to y, you're all good. All right, I hope this helped, and I hope to see you again soon. Bye.